Okay, there are very different mechanisms when we start talking about cutting something that's fragile or brittle, like glass or stone. And we have to consider, firstly, piercing the material. Okay, you've got your water stream coming down here, and let's just remember, waterjet cutting is an accelerated erosion process. We are accelerating, we're actually taking potential energy to kinetic energy. We're going from 60,000 or whatever the pressure is, psi, to 2,000 miles an hour. That creates a vacuum, it draws the abrasive in, it mixes up with the stream. Now the abrasive is mixing with the water, and it comes out as the purpose of the water is to accelerate the abrasive so it does the erosion. Okay. When this comes out, if you can imagine it at 2,200 miles an hour, imagine if I went and I took a fire hose and had it turned on absolutely full blast and walked up to a thin sheet or maybe a car window. It might just blow the whole car window right out the other side. Well, what happens is when you come along with the water and the abrasive, it's going to come down, it's going to impact on the material, and if it's too powerful, it's going to shatter the stone. You'll see two typical kinds of things happening. First one would be you see a crater pop out the top of the stone. That would typically be because you came down with too high a pressure, the abrasive and the water maybe wasn't even mixed, maybe the abrasive got clogged, maybe the water came down by itself, and it comes down. As it comes down, the mechanism is this, okay, if you can imagine. Here's your stone, here's your water coming down with your abrasive, and it comes into this hole, and it does its erosion at the bottom, and now there's nowhere for it to go other than back up. Well, while it's coming back up, this is coming down, and in that process you get a tremendous amount of horizontal pressure because it's trying to come up while the water's coming down. There's nowhere for it to go, it can't go sideways, but you get huge forces sideways because there's nowhere else to go. In stone, because it's fragile, that will create, and depending on the fracture planes, it'll just pop it right out. And that's why you get that. So when you walk along and you see there's your piece of granite and there's a little crater on the top of it, this is what caused it. And we'll talk about the ways on how to address that. Okay, another thing that you'll see sometimes is a crater on the bottom. You might not have a crater on the top, but you might have a crater on the bottom. You might have a crater on the top and the bottom. What's happening there is you have your stone, you've got your water and abrasive coming through, and maybe you've been able to figure out and perfect how to make sure you don't pop the crater off at the top in the piercing. We will cover and give you all the guidelines on what to do. Well, as you get further down, so you might start to increase the pressure at the pump, you might just start make a few changes, and as a result you start to get more and more pressure. Of course, as everything's coming down and this is coming up, you still got the same mechanism. Again, it just starts to build up with so much pressure with this pushing down, and you do have a vertical component that suddenly, bam, it just pops off the bottom. So there's often you will get top and bottom, okay? Top popping off like this, bottom popping off like that. Generally, if you were doing some kind of bowl, you would always try to lead in as far away from the edge as possible in case you pop the crater out, because once you start cutting, it's highly unlikely, unless you get a blockage on your abrasive, it's unlikely that you will start to tear the stone apart, or if you cut too fast, it'll tear it apart. Remember, we said it's an erosion process. You are trying to erode the material away. And the faster you go, you will eventually land up with a tearing process. So if here's the material, and our stream always has a drag, we're going in that direction, you're allowing that the abrasive to come and erode everything away and come out the bottom. Well, as you go faster and faster, so this is going to become bigger and bigger, and in the end, instead of eroding its way, it actually starts to tear its way through the material. And you'll find that it starts to just literally break up and crack on the bottom, or chip. So that's the only time that you would really start to get damage on the stone. But for this reason, you would typically pierce away. Getting close to the end of the session here. Obviously, that's not always ideal. If you've got a sink, you don't want to destroy this much material every time that you put a sink in. You really want to use this material and tell the person that as a thank you, you made them a little table, which is what we used to do. We'd say, hey, give us the job, we'll take that middle material, we'll polish it up, and we'll either inlay your name or we'll make a little table for you, and now you've got a little, and that will be a gift from us for thank you for using it. No one else can do that. If you've taken an angle grinder and hacked this thing to death, that's exactly what happened. So we really want to be able to pierce as close as we can and come in, or in some circumstances pierce on the line, especially if you're doing an inlay. You want to have two heads cutting two different colors and then put them together. And you can't afford to have a big ugly lead-in, which then limits that capability. So there are ways to be able to try to pierce as close as possible, and whenever we offered the table, we always made sure that the table looked a little bit like this, and we always did our lead in there just in case something went wrong. So they still got their table, you still got your cutout for your sink, and there was no damage, or the least amount of likelihood to the damage to the material. So that's a little bit about the piercing and what can happen at the bottom as far as cutting. As soon as you lose abrasive, you will just destroy. When you do your test cuts, lay your materials out, take your Waterjet and run it across with abrasive, do your test cut for fun, go and turn the abrasive off. So start your cut. Now it'll make a huge mess, okay? Go slowly, but watch what happens when you turn the abrasive off, so that you at least know what to look for and what to recognize that you had a blockage in the material and that's what destroyed it. You'll be able to see, hey, there's my problem and that's what I've got to address and that's what I've got to try and figure out. So try to preempt some of these things and intentionally destroy stuff so that you know how to go back and fix it. Okay, we'll move on to the next one after this.